Hi everyone, welcome to another video. Today we're looking at the paper Few Short Natural Language Generation by Rewriting Templates by some authors from Google Research. The paper is about task-oriented dialogue, a task that is very relevant for virtual assistants like the Google Assistant, Alexa, and Siri, which enable interactions with users, and you can do stuff like potentially request booking a table at a restaurant for 6 p.m. today, for example. And so, to give you a brief overview of this paper, the authors propose a new approach of generating fluent language that could be used to return to the users of these systems. And so here in this figure, we have a typical architecture of the task of task-oriented dialogue. And so given that you have some user requests like book a table at a restaurant for 6 p.m., you have actually a number of components in a pipeline to be able to achieve this typically. So you have first a language understanding and state tracking component, which actually is able to understand this user request and convert it to a more machine understandable type of format, such as figuring out the intent of the user, what he wants. The target entity here is the restaurant, Cascal or something, the time of the reservation and the date. Then given that you have this information, you have some other component which is generating a policy about what is the best response that needs to be generated to the user. And the output of this policy is actually typically, again, in some more machine-like format. For example, affirm that this is possible and make a request to the user about the number of seats that need to be reserved. This policy is generated by using some APIs, for example. And then finally, you have some natural language generation component, which takes this text or this input, which is not so human, natural to humans, and converts it into a more natural response, like sure, for how many people. And the authors of this paper focus in particular on this natural language generation component, and in particular making this natural language generation component fluent and trainable on little amounts of data, which is very important, and also making this component more generalizable towards unseen topics, because you could have potentially a huge number of topics that need to be covered by the assistant, like not only booking a restaurant, but booking a movie, maybe asking some general question, and this might involve a lot of manual engineering to support all of these into the APIs, into the natural language understanding components. So they try to reduce these efforts such that you can have, from any type of policy, you could have a fluent response produced that could serve the user. So here we have an example overview of how the system that the authors propose works. You have another user input. Is it a good restaurant? Are they expensive? And the way the system works is, given that you have already the response generated by the policy here, so you already have this given. For example, you could have offer intent, reserve restaurant, and inform that the price is expensive, inform rating equals to 4. So their system they actually have 3 different flavors of the system, and all of them are based on the T5 text-to-text transformer encoder decoder model introduced by Raphael et al. In 2019, which is basically a transformer model pre-trained on large amounts of raw data, and it's trained to kind of denoise data to, for example, take a shuffled text and restore the original order. And so this model has already a lot of knowledge embedded into it, and they want to use this knowledge and try to adopt it for this task-oriented dialogue task. So you have 3 flavors of the system. The first One is just taking directly this machine-generated input and inputting it into the T5 model directly without making any adjustments. And then you fine-tune to generate the desirable response. It is a fancy restaurant with a 4-star rating. Would you like me to reserve a table there? So obviously there's some problems with this, that this might not be, this is a kind of mismatch from the original type of training data that the T5 model has been trained on. It has been trained on natural language input. So it's a drawback of using this as input directly, because obviously you would need some more training data potentially to be able to learn this transformation. So what they do is actually they have some other approaches, and in particular the most successful approach is defining some very simple templates, minimal type of templates, which take these rules and generate a sentence for each of those. So for example, you could generate, would you like me to make a reservation at a restaurant? Could be one sentence. Another one could be, is it an expensive restaurant? Another one could be, its rating is 4. And actually, so these are all like pretty trivially generated. There's nothing sophisticated to do this. And as you can see, there's even, they're not really matching. There's some repetition of restaurant and so on, and they're not like fluid. But basically they're using these templates to generate this intermediate text, which is more accessible to the T5 transformer, and then they can use this and try to generate the fluent output. And this is how the basic system works. And these are actually the different types of input templates to the transformer model that they're using. So you have the naive, you have the slot description. So both of those are a little bit crude looking, I guess, for a human. And then the template one is a little bit more natural, as I showed before. So the authors test their system on 2 datasets, the multi-WOS and the SGD NLG dataset. The first one, multi-WOS, has 7 domains. The second one has much more, 20 domains. And they actually do some new preparation of this dataset where they reserve some domains as unseen domains. So they have 2 datasets. They have some testing datasets. Well, they have 2 testing datasets. One testing dataset is containing seen domains, so domains already in the training dataset. And another dataset, testing dataset, is containing unseen domain also, because they want to test whether their approach can work well, can generalize well to unseen domains. And yeah, so as you can see, for example, these are the number of training examples. It's actually not a huge amount. And they test their model, and they also compare a few previous baselines on this dataset. So let's look at some results. First, comparing their approach, which is actually their final best approach, is called T2G2. We compare that one to some 2 baselines here on this multi-WOS dataset. And this naive is again the approach of the authors of this particular paper we're reading right now. So for this dataset, they actually are able to achieve state-of-the-art performance with the native approach here, and outperforming the 2 baselines where, for example, this baseline is a GPT-2 style baseline. And another interesting experiment, perhaps more interesting even, one could say, is how will this work when evaluated on seen or unseen testing examples. And here they're comparing their 3 different approaches to generating native text. And it seems that this T2G2 is much better is actually better at generating seen examples for this other SGD and NLG dataset. And it's also working the best for unseen examples, which is nice to see. That it's capable of achieving good performance, well, actually, I'm not sure how meaningful these numbers are in comparison to previous systems, because there's no other system like the other baselines, but it seems that it's working the best out of the 3 variants proposed in this paper. And also another interesting result, actually, they do a human evaluation of these 3 different approaches, where they are evaluating the naturalness. They're asking humans to rate the naturalness of the responses on a scale from 1 to 3, where 3 is better, as well as the informativeness of the responses, again, on a scale from 1 to 3. And here they're comparing their 3 approaches to text generation, response generation, versus human-generated responses. So they ask some humans to manually write responses to the questions, and they again rate with another set of humans. They rate under the same metrics the human-generated responses. And actually, interestingly, what they find is that their best approach, T2G2, seems to perform slightly better than the human-generated responses for both the evaluation questions, which is a very interesting result. It seems that T2G2 is sometimes is able to generate better responses than the human. And I'm not sure why this is the case, but if I have to speculate, perhaps T2G2 is better able to handle somehow the knowledge provided by previous steps in this pipeline. I don't know. But very interesting. And then a final experiment that I wanted to show is regarding few shot generations. So they test whether their approach can work well when you only have like very few of those examples in the domain that you're interested in available. Let's say you only have 5 training examples for generating responses about restaurants, or 10 or 20 or 80. And so they're comparing how does this perform. And actually, it seems that if you only have 80 training examples for this few shot response generation, you're actually able to reach a performance that is not very far off from the model trained on all the training data available in terms of this blue and this SER metric, where low is better. So this is very interesting, and it just demonstrates the power of this pre-trained models for text-to-text rewriting, like the T5, and their flexibility to be adopted to a wide range of tasks. And it's interesting what else they could be used for, actually. And so this was the main things that I wanted to cover for this video. In overall, it's an interesting approach for generating natural sounding text from rough text. This task is actually probably relevant to other tasks where you have some rough text and you want to improve it. There's a lot of such tasks like, I don't know, correcting noisy user text, or I don't know, improving machine generated text could be another one. And actually, one thing that I am not sure about, that I didn't read in detail, I'm also not so familiar with this particular field, is what is the dependence of these particular components that are also part of this pipeline? Like, could it be that the high performance comes because of the high performance of these particular components? It could be that I did discuss somewhere in this paper, but I didn't look into it too much. And so that is all that I wanted to cover today. Thanks for watching, and subscribe for some more upcoming NLP videos.